In this video, we are going to find an analytic function for which the real part is e power x into x cos y minus y sin y. Now take this whole equation as u. Now we want to find ux, uy, ux of z comma 0 and uy of z comma 0. Now first we are going to find ux. In order to find ux, here two terms are there, so we are going to use uv method, which is u dash v plus uv dash. First we are going to find u dash, which is differentiating u with respect to, here u is e power x and v is remaining x cos y minus y sin y. Here u dash, differentiating e power x with respect to x is also e power x, so same. Now v is x cos y minus y sin y as it is, plus u as it is here. Then v dash, if we differentiate this with respect to x, we get here x, differentiating x will get 1 into cos y minus, here there is no x term, so 0. 1 into cos y minus 0, it is cos y. We got ux. Now we should find ux of z comma 0. Here nothing is there. Ux of z comma 0 means wherever x is there, substitute z, and wherever y is there, substitute 0. Now e power x is e power 0, x is z cos 0 minus 0 sin 0 plus e power z cos 0. Cos 0 is 1 and sin 0 is 0. E power z, here z into 1, cos 0 is 1 minus 0. E power z into z minus 0, e power z into z plus e power z into cos 0. Cos 0 is 1, so e power z. Here we are taking e power z as common, so we will get e power z into z plus 1. We got ux of z comma 0 also. Now we want to find uy also, same uv method. Here e power x is there, so there is no y term, so this e power x will become 0. Then v as it is plus e power x, u as it is e power x. Then differentiate v with respect to y. Here x as it is, cos y is differentiation of cos y with respect to y is minus sin y, so minus x sin y minus already there. Then here y sin y is there. Now we want to again use uv method for y sin y. Here u is y and v is sin y. Now u dash, differentiation of y is 1, v as it is plus u as it is y, and v dash, differentiation of sin y is cos y. So simplify, we will get 0 into anything is 0, so this will fully become 0. And take this minus, here also minus, here also minus, to outside, e power x into, now inside fully become positive, so x sin y plus y sin y. Now we got uy also. We want to find uy of z comma 0, so wherever x is there, substitute z, wherever y is there, substitute 0. We will get minus e power z into z sin of 0 plus sin of 0 plus 0 cos 0. Inside the bracket fully will get 0, because sin 0 is 0 plus sin 0 is 0 plus 0 into 1, cos 0 is 1, anyway 0 into anything 0, so inside the bracket we will get 0. minus e power 0 into 0 also 0. Now we found out all the four things. Now we know f of z equal to u plus iv. If we differentiate this, f dash of z equal to ux plus ivx. We know that from CR equation ux equal to vy, uy equal to minus vx. So in place of vx, we are going to substitute uy. So f dash of z will become ux minus iuy. Now here f dash of z is there, but we want f of z only. So we are going to integrate ux of z comma 0 dz minus I into integral uy of z comma 0 dz plus c. Here ux of z comma 0 is here, we already found out. Substitute that in this formula, and uy of z comma 0 is 0, so 0. Now we want to integrate this. Now we cannot integrate as it is, because it is involving exponential function as well as algebraic function. We studied in lower class that isolate. Here a is algebraic and e is exponential. Here algebraic is coming first in this, so we want to write u as algebraic function, u as z plus 1. Differentiating this, will get du equal to dz plus 0, that is du equal to dz. Now exponential we want to write as dv equal to e power z dz. If we integrate this, we will get v equal to e power z. Now this we want to substitute here uv minus integral v du. U is z plus 1, v is e power z minus integral e power z dz. Z plus 1 e power z minus integral of e power z is also e power z plus c. Now take this e power z as common, we will get z plus 1 minus 1 plus c. This plus 1 minus 1 will get cancelled. Now the last answer is e power z into z plus c.